Okay, we're going to take a look at number 14. Number 14 on page 537 from the 429 homework. These are equilibrium problems. Okay, in this problem here, they tell us phenol, okay, C6H5OH is used as a disinfectant. If the equilibrium concentration of phenol is, okay, what are the concentrations of H3O plus and C6H5O minus? KQ for phenol is, okay, and so what they're assuming that you can figure out here is the chemical equation first of all. Okay, remember we're trying to find, we want here to know the concentrations of H3O plus and C6H5O minus. Okay, so we want to know the equilibrium concentrations of those. They tell us KEQ. We're given KEQ, and we're given the equilibrium concentration of phenol, which is C6H5OH, which they tell us is equal to 1.61 times 10 to the minus 3 molar. Okay, so the thing we want to do first is to write our equilibrium expression, but to do that we really need to know the chemical equation. And so what they're describing here is C6H5OH making H3O plus AQ and C6H5O minus AQ. Okay, and for that to do that, that must have reacted with water liquid. You can see that this would have gone to here, leaving this as a bare ion. So now I can write my equilibrium expression as the product of the products concentrations all over the reactants, like this. Okay, this one here is a pure liquid, so we can cross it off. And what we're going to do is we're going to want to solve for these concentrations. And what's going to be useful to know is that at equilibrium, these are going to have to equal each other. Okay, based on this chemical equation, the molar coefficients tell us that these have to be equal. Right, it's a 1-to-1 ratio here. So what we can do is we can, when we write in our values here, we can say 1.61. Oh, hold on. Our KEQ. Let me erase that. Our KEQ, they tell us, is what? Is 1.60. 1.60 times 10 to the minus 10. And that's equal to these up here. Since we don't know them, but we know they're equal, we can call them x, and it's going to be x squared. Okay, let the concentration of each of these be x, and so we're going to get x times x is x squared, and they tell us the equilibrium concentration of this one is this. Okay, and so we can go ahead and then use our calculator. To calculate what x would be. So 1.60 times 10 to the minus 10 times 1.61 times 10 to the minus 3 is equal, equal to 2.58 times 10 to the minus 13, which is equal to x squared. You can take the square root of both sides, and so square rooted, we get x is equal to 5.08 times 10 to the minus 7, and since this is a concentration that we're calculating, it's molarity, or molar. Okay, and so the concentrations of these guys up here would both be 5.08 times 10 to the minus 7 molar, and this would be your answer.